Okay, so I wanted you to graph the square root of 2x and the square root of x plus 5 in the same coordinate plane. And tell me what you notice, or use this to guide us to extraneous solutions. Well, the only way you can make sense of the extraneous solutions is hopefully this looked a little familiar. If you went back to your notes from solving square root equations, this one looked a lot like number 3 from your practice. So number 3 from your practice was 2x raised to the 1/2, which was equal to x plus 5 to the 1/2. And you were having to solve this. So the first step that you should have done was hopefully go from exponential to radical. So this is equivalent to the square root of 2x, and this is going to be equivalent to the square root of x plus 5. Oh, hey, that's where Miss Green got those two problems from. Okay, so then the next step, you want to get rid of the radical. Well, you want to isolate the radical, but because you've got a radical on each side, you can't really isolate it. So to get rid of the square root, you want to square both sides. So when I square both sides, I'm left with 2x is equal to x plus 5. And now I have the x that I need to get by itself. So to do that, I'm going to subtract the x from the 2x. And then you have x is equal to positive 5. So hopefully on number 3, that's what you got, was x was equal to number 5, or x is equal to 5. And if you go back and look, how are these two related? How are the graphs related to our solution? Well, take a look. Look at this point that I have highlighted right here. Where do these two functions cross? So these two functions cross or share a common point at 5 and 3.16. Well, hopefully that 5 stands out and looks familiar. Do you see how that's the value of x? So when we set these equal to each other and we're trying to solve them, if you graph them in the same coordinate plane, you can find their point of intersection, and the x value is your solution. Okay, so let's take a look at the next one. So the next one, hopefully you recognized how this one come from our example in our notes. This was example number 2. Remember, this was an example that had an extraneous solution. So I'm going to go back and review how to solve this. So we've got the square root of x plus 7 minus 5 is equal to x. Okay, so the first thing you did was add the 5 to both sides. So we got the square root of x plus 7 is equal to x plus 5. Okay, then to undo the square root, to get rid of the square root, you square both sides. And you get x plus 7 is equal to. So since we've already done this one in our notes, I'm not going to go through the details, but when you expand it out, you get x squared plus 10x plus 25. Okay, so then remember how you want to set it equal to 0, because you have a quadratic function and you need to figure out what those values of x's are. So when you do that, you get 0 is equal to x squared plus 9x plus 18. And again, guys, this comes straight from your notes, so you can go back and watch the other videos if you're not following along with these steps. And then to solve this, you can use factoring. So when you factor, your factors are x plus 3 and x plus 6. And so then you got the solutions, x being equal to negative 3 and x is equal to negative 6. And remember how we said that negative 6 did not work. That one was an extraneous solution. Well, take a look at your picture. You see, if you graph these two functions, if you graph the function the square root of x plus 7 minus 5, and then you graph the line x, Notice how that line and that square root, they only cross and they meet one time. And so the point that they share, the point where they meet, is the point -3, -3. So you see why they only have one point in common? They share an x value of -3. -6 is nowhere in this picture, and that is why -6 is an extraneous solution. Okay, so one more. This one come from your homework, and I'm going to start it in another video so my videos don't get too long. So make sure you watch the third video.